Okie dokie. So in this video, welcome to chapter 5. Welcome to chapter 5. We are going to do an intro to circles. We are going to go into some circle trig, short for trigonometry. And then we're going to look at the trigonometric graphs. Okay, so that's a big, it's not a big unit, I wouldn't say. Oops, sorry. Okay, sorry, my bad. It's not a big unit, but it definitely is all brand new. For most of us, I would say. There might be some similar things that maybe you saw a little bit in math too, but I don't really think that they go over circles in math too. So this is all very, very new. So let's go ahead and dive in. Um, Lesson number one, 5.1, let's call it 5.1, okay, is going to be about this thing called a central angle and the measure of the arc that it creates. Okay, so what I want you to visualize in this first section is a pizza or a pie or something circular that you love. Okay, we're going to talk pizza. If you want to talk pie, that's fine, but I'm a pizza person, so let's talk pizza. So if I cut pizza, okay, a slice of pizza, then what happens is that I have this triangular shaped kind of here at the bottom, and then I have this little crust. Okay. The crust is going to be what we talk about later in this unit, but the angle that is created at that triangular bit is called a central angle. Whoopsie. It's called a central angle. The angle that is created by cutting a slice of pizza out is called that central angle. So what is a central angle? It's an angle with the vertex. So there's a little math two word for you. The vertex, which is this middle point, that middle part of the angle, at the center. Okay, so circles have centers. We know this. That's elementary, middle school level. Circles have centers. If I throw an angle, okay, an angle in a circle where the vertex of that angle is centered on the center, um, then it's called a central angle. So at the center of the circle, and its two sides are the radiuses, but they're called radii. Okay, the two sides of the circle or of the angle, sorry, of the angle are the vertex. I'm sorry. Words. Okay. I've got an angle at the center. Okay. The two sides of my angle are the radii of the circle. Sorry. Okay. So how do we label an angle? So in math two, you should have talked about labeling an angle. So if I have an angle, let's call it A, B, C. You guys labeled that like this angle, or you did the measure of the angle A, B, C. You start here, you go to the vertex, and then you end with that third point. Now, could I label it CBA? Absolutely. Could I label it BAC? No. Could I label it CAB? No. The vertex is always the middle letter. Okay, so 5 minute, 5 second, two math two lesson. Okay, so for example, the central angle in this circle B is going to be ABC. Okay, and I'm going to even put angle ABC. Now, the sum of all central angles, so if I have like a ton of central angles here, right? If I just created a bunch of different ones, let's say I put one right there, la 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 la, all of the central angles adding up, because that's what sum means, is the total of a circle, which is 360 degrees. Okay, cool. So the measure of the arc. So the arc that is created, we kind of talk about what an arc is. I'm going to erase these little points and I will re-highlight the measure of the angle. Okay. The arc that is created is the crust of the pizza slice. So when I talk about the arc, what I'm meaning is this portion right here. Okay. The arc is what I would classify as the crust of the pizza. So you've got the pizza, you've got the crust that's that kind of arced, curved piece. The measure of the arc formed by the endpoints of the central angle is the measure of the central angle. Okay. So the measure of the arc is the same exact degree of the central angle. Okay. Now I want to introduce you to arc notation. So you know up here in math 2, you guys did the measure of the angle. Okay. Well, an arc is measured by just a simple kind of little half circle. So if I have an arc AC, you would put a little, I guess a frowny face, but a little just rainbow, little arch, little arc measure over the top of those letters. So that says the measure of the arc AC is going to be equal to the measure of the angle ABC. Now, what is that in this case? It's going to be 84 degrees. Okay, so the measure of the arc is the exact same as the measure of the angle, so it's going to be 84 degrees. Okay, now, just like in, what do I remember from? Okay, uh, yeah. So if I decide to go and ask for the measure of the ADC, now ACD would be this right here. I can't go that way. I have to go in the order that the letters are written, just like I did in Math 2 when I'm measuring the angles. A, D, C. So I want the measure of all the other portion of the circle. And so what would I do? I would take 360 and minus 84 from it. So if I got my handy dandy, so 360 minus 84, sorry, I got distracted. That would be 276 degrees. Okay, so that's really all you need to know. 360 is a circle. The central angle is the measure of the arc. So here we go. Let's look at number 1. So it says the measure of the arc, ST. So the measure of the arc, and I'll just get my little highlighter out. You're more than welcome to highlight, but again, I just don't want you to over highlight, and then like your paper's bleeding and then you don't know what you've highlighted and then it kind of feels weird. Okay. So there's that. So ST. ST is created by this central angle, SQT. Ooh, don't want to do that. And then right here. So that angle is 122, which means that the central angle and its arc are the same. So this is going to be 122. Again, not hard math, but definitely new notation. All right, so the arc of RS. Well, RS is right here. Now, what are some things that you see? Now, we didn't really talk about this because we've pushed this into kind of the next unit with like the parts of a circle, but you guys should know the parts of a circle, okay? Let's take a second to kind of chitty chat, okay? If I have, whoops, this, which is the diameter, it's the line that goes through the center of the circle, okay? If I have the diameter, what degree is that? Good, 180. Okay, so if I'm seeing that RS right here is the other portion of the diameter, then I would take 180 and I would subtract 122 from it. And I get 58. And I know that the measure of the arc is the measure of the angle, so 58. Okay. Now, last portion, we have SRT. Now remember, you got to go in the order that they are written. So S starts here. We go towards R. Whoops. When I hold the pen too long, it makes a straight line. So S to R and then R to T. So I want all of this angle right here. Well, I just figured out that this was 58. And then I know that this is 180 because it's the other half of my circle. And so 180 plus 58 would be 238. Cool? Perfect. Cool. Number two. Now, what do you see? What you should see is this thing from Math 2 called vertical angles. And you should know that vertical angles are congruent. Bringing that little symbol back. Congruent. That means they're the same. They measure equal. I do also see some diameters. So I know that this angle 21 and then this angle are also going to get me 180 together. So if it does ask me about those things, then I can know that. Okay, but let's get to the first question. It says the measure of the arc JK. Well, the JK arc is right here, so that's also 21 degrees. Okay, the measure of the angle JNM. There's that other angle that we literally just talked about. So that'd be 180 minus 21, which is 159. Okay. The measure of the arc, KL, well, KL is gonna be right here. And if I were to go this way, it would have to be um a letter J or M would have to be in the middle. Okay. This is a direct shot to from K to L. So the reason some of you might be like, oh, okay, well, why can't I go the other way? Well, the other way bypasses more letters. And so they want you to go the shortest direction from K to L. Just like in either of the next two, JKM, you're going to go J straight to K and then all the way to M. So it's kind of the direction, the path that you would take. Okay. So KL, actually KL is the exact same as this because those are vertical angles. So JNM was 159. So the measure of KL is the exact same. Okay. The measure of the angle JKM. So we've got JK. Ooh, yeah, that's right. Sorry, not the angle, the arc. JK and then all the way to M. Now you only have to have three letters, and you're like, why didn't we have JKLM? You only have to have three letters. Okay, so it's the first one, the last one, and then some letter in between if necessary. Okay, so JKM, that's going to be two 21s, right? Because I've got this angle right here and this angle right here, and then the 159. So it's all of this right here. And that's why I don't want you highlighting too much because like clearly I am overwhelmed with my stuff. Uh-oh. Okay. Ah. Perfect. So this would be 201. And now we've got the measure of MKL. Okay. Well, if I go ML right here, if I go that direction, I'm going to go from M straight to L, and I can't do that. I have to bypass K. So M, K, and then L. So it's really everything but this 21-degree angle. So I could add them all up, or I could subtract from 360. So 360 minus 21, get me 339. Cool? All right. Well, I feel like you could do a gajillion million of those. Let's go down to number 6. Perfect. To do algebra stuff, okay? Not any more challenging, but you do maybe have to find the value of x. So here we go. We want to find the value of x. I see vertical angles and I also see a diameter. Oops. Okay. So that would mean that 15x minus 26, that's the measure of this arc, plus the measure of 26 would be equal to the whole half side, which is 180. Okay. Now 26 negative and 26 positive, they cancel out, which is kind of silly. Okay. But 15x equals 180. 180 divided by 15 gets me 12. Okay. Let's do something a little crazier. All right. Because I don't feel like that one was that crazy. All right. Oh, yeah, number 7. Okay. So we've got I only see this pair of vertical angles, if I'm being honest. Okay. I would say that 103 and then this 15 plus the 18x minus 2 would be equal, but if you don't see that, then don't stress about it. What I do see are that this right here, these two angles, HIG and FIG are 180. So I could do 180 minus the 103, which gets me, this would be 77. And then I do see that these three angles right here make a 180 line. Okay, but again, there's multiple ways to go about doing this. So what I would do is maybe I would add up 18x minus 2 plus 15 plus 77 equals 180. You could obviously subtract all of those and equal them all the same. Doesn't matter. So we got 77 plus 15 minus 2, that's going to be 90. So I'm going to minus 90. Well, that's going to be 90. And then I've got 90 divided by 18, which is 5. Okay? Coolio? All right. Awesome. I feel like you could do a million of those. All right. Next are the angles in standard form. So now what we're going to do is we're going to take this idea of a central angle and we're going to put it on an X and Y coordinate. Okay, so an angle on the coordinate plane in standard form when the vertex is on the on the origin and one ray or one side of the angle is on the positive x-axis. Okay, the ray on the x-axis, meaning this one right here, is called our initial side. The other one, so the one that is moving, this one right here, this other one is called the terminal side. Now, why? I'm not really sure. Okay, it kind of reminds me of like a terminal at an airport. Like sometimes, if your plane's flying in, your plane might end up needing to go to a different terminal. And so terminals of planes end up changing all the time. So maybe that's how you remember it. All right, here's some weird stuff. Not that anything we haven't done this semester isn't totally weird. I don't know why I preface it with that because you're like, freak, it's all of it's weird. Okay. Counterclockwise, meaning going backwards in time. So from the initial side to the backwards motion will result in a positive angle measure. Isn't that great? Love that for us. Okay. If I decide to go clockwise, meaning with the hand of the clock, so forward time, meaning from the initial side backwards, kind of this way in the motion of time, like this. Okay. Then that's going to result in a negative angle measure. Don't you love that? This is a negative. This is a positive direction. One entire revolution is a circle, so 360 degrees. So our goal right here kind of at the beginning is to just be able to sketch what an angle on an X and Y coordinate grid would look like. Remember, we have our initial side. That's going to be the one that's at our X-axis. That one's always going to be there. So you honestly could go in and you could sketch your initial side. You're always going to have a side that starts at that x-axis, the initial side. And then the one that's going to move is going to start from the x-axis and is going to move either in the clockwise or the counterclockwise direction based off whether it's positive or negative. So let's be very clear. This right here has angle measures that make sense, right? If I go here up to the y-axis, that is a 90-degree angle. Sorry, I'm hearing weird noises. If I have this to that, that is a right angle, okay? If I keep going, that's 180. If I keep going, and I guess I could stand up and show you, but that's 270. And then if I make one full rotation, that's 360 degrees. So if I want to go 75 degrees, and if I want to sketch a 75-degree angle, am I going to go all the way this direction? No, I'm going to hit shy of 90 degrees. Now, again, it's a sketch. It is not a perfect angle. I'm not asking you to get your protractor out and measure it, okay? But ye perfectionists, fine. But I don't even own a protractor because we don't even use them anymore, okay? So I want to go shy of, I want to go a little more than halfway, right? Because I know 45 is halfway. I'm going to go a little bit more than that. That's going to be around about the 75-degree angle. And then I'm going to draw my arrow that tells my direction of what my terminal side went. So from here all the way up to here, that would be my 75-degree angle. Okay? Make sense? Cool. Now, 170, but, or 160, but negative. So that means I'm going to have to go this direction. Now, this direction is negative 90. This would be negative, oh my Lanta. Negative 90. This would be negative 180 if I'm going to still go this direction. So I need to stop shy of that 180 and it be kind of right here. So something like that. Again, not perfection, estimation. So if I ask you to kind of just guess and sort of kind of do. Okay, cool. All right, 430. So I know that I'm going to need to make one entire revolution in the counterclockwise direction. So that's how you would rotate a little spiral. And then you're going to go a little bit more. But what is the little bit more? What is minus 360? Be 70. So something right about here. And you do have to notate that you went one full revolution. Cool? Awesome. Perfect. And that is how you sketch angles. All right. Next and last thing for this video would be going and introducing you to a new way to measure angles. So we have measured angles in the form of degrees, right? 70 degrees, 75 degrees, 90 degrees, 130 degrees. We've always looked at this thing called a degree. But unfortunately, for you and for us, there is a different way to measure angles. Just like there's inches versus, from one system to the other system, we got meters, we got yards, we got, I know for us in swimming, we have a yard pool versus a meter pool. And while they might say 25 meters, 25 yards, they are not the same because they are different metric systems or they're different measuring systems. So it's very similar in the fact that it's just two different ways to measure an angle. They're the same, so it's not like meters to yards, but they are the same, but it's degrees and this word called a radian. Okay, and so a radian is a unit of angle measure based off of the arc length. Okay, now we talked about at the very beginning of this lesson that an angle measure, right, the central angle and its arc needed were the same. Okay, and so 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. How exciting. Okay. So if the radius right here, here's what this means. When the radius is equal to the measure of the arc, when those two things are the exact same thing. So when your pizza slice edge and your arc, your crust, are the exact same measure, then what you have created is a radian. Okay. And so if I go all the way around my circle, okay, this is asking you to remember circumference. Now, we haven't talked circumference yet. Okay. That's in the next chapter, but it says the circumference is 2 pi r. Okay. Therefore, if I make one entire revolution, this would be 2 pi. Because the radius is 1. Okay. 1 radian, 1 radian, 1 radian. Okay. The radius is 1. It is 1 radian because the radius and the arc are the same. So 2 pi, 2 pi r. R is 1. Okay. One specific radian. All right. And then 180, which would be half of that, would just be pi. Okay. Your job is to be able to convert from degrees to radians and radians back to degrees. So I gave you two formulas. I can give you these, but you probably should get them in your brain. Okay. Because they do not give you these formulas for the EOC. Shocker. Right. Okay. If I want to go from degrees to radians, so from degrees, if I have degrees to radians, then what I'm going to do is I'm going to take the degree and I'm going to multiply by pi over 180. So this is kind of a weird little thingamabob. If I want to go from degrees to radians, I'm going to take the degree of the angle and I'm going to multiply it by pi over 180. And I'm going to get that answer. Now, here's what I don't want you to do. I do not want you to plug in your calculator because you're going to get this wicked nasty decimal and you're going to hate everything. And I don't even really want you to use 3.14. Okay, I want to show you what I want you to do. So you are going to times by pi over 180. Now, if you take it back to our chapter prior, we've done this, multiplying the fractions, okay? 30 is like 30 over 1, okay? So I'm multiplying numerators and then denominators. So this would be 30 pi over 180. Now, the only thing that I want to do in order to simplify is I want to simplify the fraction, not the pi, the fraction. So I want to do 30 over 180 and enter. Ooh, I do not like that. Okay, and so with that said, 30 over 180, that is not what I want. Boop, 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 boop. Wow, why do I have so many apps open? Okay. Okay, 30 over 180. And then I can click that little thing to make it a fraction. So 1/6. Oh no. I totally shut out of that app. Crazy. All right, so this would be 1/6 and then pi. Now, you guys know and I know that we don't need to write the 1 in front of pi. So this would actually, the best answer would be pi over 6. How exciting. Pi over 6. Okay, welcome to the new weird. All right, cool. Degrees into radians. I'm going to times by pi over 180. This would be 150 pi over 180. And then I'm going to simplify my fraction. Now, if you're in your handy dandy, you could do 150 divided by 180. Enter, math, enter, enter, and that will reduce your fraction for you if you are not confident in your reducing skills. Okay, so 150 over 180 and give it to me as a fraction. Oh, cool. 5/6. So 5 pi over 6 would be the radian measure of 150. Perfect. Next, negative 220. So again, timesing it by pi over 180. This is going to be negative. That doesn't change what I'm using to convert. It just makes my answer negative. Okay, so negative 220 pi over 180. Again, we're not plugging pi into our calculator. We are simply doing 220 over 180. And again, that is negative. So it'd be 11 pi over 9. But it'd be negative 11 pi over 9. And you always want to reduce it because we are eventually going to need it reduced. Cool. Let's go the other way. Yeah, perfect. So if I convert degrees to radians by multiplying by pi over 180, to go the other direction, meaning to go from radians to degrees, I am going to multiply the radian value by the reciprocal. So 180 divided by pi. Okay, so here I go. I'm going to take 4 pi over 3 and I'm going to multiply it by 180 over pi. So again, take my mindset of multiplying fractions and do the same thing. Okay, so you could slap it all in your calculator if you want to, but do not plug in the pi's. Okay, because you're going to see what happens here in a minute. So 4 times 180, because that's my numerators, it's going to be 720 pi over 3 pi. Okay, so you guys know from that chapter of rationals, anything that you see on the top and the bottom can reduce. So pi over pi nixes and goes away. They can go away. So all I'm doing is 720 divided by 3. So 4 pi over 3 into degrees is 240. All right, times by 180 over pi. We do 5 times 180, which gets me 900 pi over 36 pi. And again, this is negative because that negative's right there. My pi's go away. 900 divided by 36 gets me 25, and it is negative. All right, last but not least would be 180 over pi. 7 times 180 equals 12. That's a big number. 1260. Oh, well, okay, yeah. Pi over 4 pi. So again, the pi's go away, and 1260 divided by 4 is 315 degrees. Okay? So I believe, I actually don't think I put this in the back of y'all's packet. No, I did not. All right, so you now have Delta math homework that is going to practice all of this. Central angles, angles in standard form, and then converting from degrees to radians. So I shall see you in the next video. Ooh.